Uh, First of all, thank you everybody for joining. Let's hope today will be a great session. Yeah, I see all of you are writing from which parts of the world are you? So yeah, depending where you are, good morning, good afternoon, or good evening. Where I am here in Riga in Latvia, it's already evening, so here it's already 7 p.m. But yep, so for today, this webinar slash workshop will be primarily focused on flight planning for LiDAR sensors. But also, I'll introduce you to some new features that we have added to the latest version of EGCS, so specifically version 5.17, which we actually released at the beginning of this week. And yep, after that, we'll do a bit of a workshop with the software itself. I'll show you different tools for LiDAR, also show you some tools that were added just very recently. We'll talk about how to use DTMs, DSMs, and also I'll try to answer any questions that you guys might have. So yep, without any further ado, let's get right into it, at least let's get into the next slides, I guess is what I mean. So yeah, first of all, for the agenda, I'll do a bit of introduction. Then, as I mentioned, I'll talk about what's new in the latest version of UGCS. After that, we'll dive into the software itself. I'll show you the ins and outs of it as much as I can within our time constraints. And we'll specifically focus on the features for planning LiDAR missions, what are the differences between different sensors, and how to do it best. And then also towards the end, I'll talk a bit about pricing, what options are there, and we'll do a bit of a Q&A. But yeah, I'd like to ask if you will have any questions during any part of this workshop. Then there's a Q&A section here in Zoom, so I would kindly like to ask you to put all the questions there. That way, it's just a bit easier for me to get a better overview of everything. So please put the questions not in the chat, but in the Q&A, because then also they get saved. And maybe if there's some question that I don't get to answer in today's session, then later on, we can also reach out to you and talk to you more directly. So yeah, I think that the approximate time for today I'll try to aim for about 1 hour, not to take up too much of your time, but with the Q&A, it might also take a bit longer. But the questions I already explained, so please make sure to put all of them in the Q&A section here in Zoom. In case maybe you cannot make it until the end, then this recording will also be sent to everybody registered afterwards, so you will be able to watch it later. And also here on the screen at the bottom right, you can see that's the QR code to join our Facebook group. So if you don't know yet, so we have a Facebook group of UGCS drone pilots. Currently, it's already more than 4,000 members and very rapidly growing. So yeah, if you want to talk more with different pilots and for what they use UGCS and discuss general drone surveying questions, then you're very welcome to join. So either scan the QR code, or if you just type into Facebook search bar UGCS users, you will also be able to find it. So yep, now let's proceed to the next slides. So I'll try to start off with what's exactly new in version 5.17. So firstly, what's I think quite exciting is we have added support for some new drones that were also requested. So first of all, we have now also support for the DJI Matrice 4D and 4TD models. So these are the models that come with the DJI dock, but as you might know, they're also sold separately. So just to be clear, we do not yet support the dock station, but these drone models, when purchased separately with the controller, these can now be fully used with UGCS. Also, some, I suppose, interesting info in case you're not that much aware of these drones. So they, like compared to normal Matrice 4D, Matrice 4 Enterprise and for thermal versions. So these these dock versions, they are weather and dust resistant. So they have an IP rating, which is really great, and also they have a longer flight time. So in case maybe you have been looking for such a drone, it's just something you can consider, I suppose. Then also we added a new profile for the ArcSky X55 industrial drones that's also now available. And then also there's also new payloads available in GCS for the Sony ILX LR1 camera with 3 different lens options, and for the Phase 1 P3. So these profiles previously were available on our manual site, so you could download them and import, but now they are inside of GCS by default. So that's starting from version 5.17, which is live now on our site. Also, for those of you, especially in Australia and USA, what cool new thing has also come out now is the measurement unit switcher, which may be a long time coming, I know, but now finally it's here. So if previously you were able to simply switch between metric and imperial, and you weren't really able to adjust the units that much, so now you can. So first of all, we've made the speed in imperial units make a bit more sense. So now it's in miles per hour. So similar as you would find in DJI apps and in other drone apps. So that's kind of the standard. So yeah, now we kind of standardize this a bit. We also added aviation measurement units, since I know for some users actually have requested to be able to see the speed in knots, measure distance in nautical miles, measure the vertical speed change in feet per minute. So now these units are also available, and so you can see in this toggle, if you go to the custom section, then actually you can choose a mix of different units. Maybe for some units you want metric, for some you want imperial, for some you want the aviation. So now this is also available. So in case you've been waiting for this, so now now it's here. Then also we have updated the recently released calibration pattern for YellowScan LiDARs. We'll get, since today is also a LiDAR webinar, we'll get into it in just a second. But in short, we have made the segment more adjustable. So now you can set the length and the flight speed, since the drone has to reach a certain speed to be able to correctly calibrate the IMU of the LiDAR. And also we've made it a bit more efficient by shortening the part after the turn. So now it's this U-turn J-hook calibration. So now it is a bit more updated. And also, in case you maybe have been using some bathymetric sensors, now there's also some really good news for you. So we have added the hop action. And what hop action does is, if you have heard of what is grasshopper in the world of drones, at least in kind of context of our software, so this is the possibility for a drone to, as it's doing a bathymetric scan with an echo sounder attached to it. Sometimes you don't want the sensor to be in the water all the time. Sometimes you want the drone to stop, then lower itself down, and then do the measurement, then again go back up and proceed to the next measurement point. That's what we refer to as the grasshopper mode. And now for this, we have added a new hop action, which does exactly that and allows you to plan these types of missions more easily. So you can set the interval, descent altitude, descent speed, and for how long should it wait. So it can be used with echo sounders and some other sensors, and even there's a possibility to use water samplers with this. So if you have been doing these missions, or maybe you're considering expanding your business, then also this is something you can consider. But yeah, now that's kind of it for the preliminary part of the presentation. So now let's dive into the software itself, and let's take a bit more closer look at what LiDAR tools are there. Let me just very quickly see, maybe there's some questions already here that I can answer. But yeah, I'd say let's go into the software, and then I think all the questions I've seen for now, I'll try to answer them already within the software. Yeah, now you should be able to see it, hopefully. So this is GCS, and from what I understand, some of you are already familiar with this and want to gain a bit more in-depth knowledge, but usually also we have newcomers in every single one of these workshops. So I'll kind of try to take you through this, at least starting from maybe some basics, and then we can get into a bit more advanced stuff. But I'll try to be somewhat quick and kind of so we can be also efficient with our time. So firstly, of course, you can see this map is all in 3D. And I think maybe as the beginning, I have prepared actually a few elevation models, a few map overlays, just to demonstrate what the software can do. Because before we go into the flight planning itself, I think it's just a good idea to look at the map, because very often, especially when you are doing LiDAR surveys, I think it's important to also make sure that the elevation model you're using is good. So now let's start by opening the map overlays window. This is available up here in the top bar. So now let's click here on map layers. I'll just bring this window here to the center. Let's see, maybe I can just increase the size here a bit so you can see it more easily. So first of all, we are in the map section. So I'll maybe talk about this one first, and then we can go into the elevation models. So UGCS does come with some map sources already available to you. So you'll see at the beginning, once you install it for the first time, you'll have Google Maps available, so Google Satellite and Hybrid, as well as Bing Maps. And so this base map you can also easily change. You can, for instance, go to Bing, and now you might have noticed that the base map also has been updated. And now also we can, for instance, turn it off and it will go back to Google Satellite. Now I have loaded a few of our own map overlays just to demonstrate what you can do with this. Because of course, sometimes, especially when you zoom in to the map, then it might not be as detailed as you may want or may not be as updated. So the satellite imagery might be a bit outdated in certain places. So now let me maybe let's start from this example. Let's take this large map overlay. Here you have the button to focus in on it. So now let's jump over here. And now let me just quickly, for the beginning, I'll just disable it. This is our office and the drone test range where we fly usually. And so now you can see as I zoom in, then of course, at some point you reach the level where, you can't really see very detailed objects on the map. Very often it's okay, so you don't always need to have super updated map, but there are cases when maybe some building that if you're scanning, for instance, a construction site, maybe the building there is not yet visible on the satellite imagery. So when you're doing the flight planning, especially if you want to fly around it, you might want to have more updated map. So if you have a GeoTIFF model of the map, which you can process using basically all commonly available mapping software like Agisoft, RealityScan, then you can also import this into UGCS. So now I'll take this big orthophoto that I have. I can add it in here. The upload process, by the way, it's very simple. You just create a new layer and then you upload that GeoTIFF file here. And now you can see, of course, we see a lot more detail. So you can see, of course, the cars. If you're knowledgeable about cars, you can even recognize the models. Well, what I'm getting at is that, of course, here you see a lot more detail. And this means that when you are doing your flight plans, you can be a lot more aware of if there are any obstacles. For instance, here you can see there's some shades here. Here you can see the fence. And yeah, things like this is what you also need to be aware of when you are planning your missions, especially when this is done over some, let's say, construction sites. And here in the GCS, you can actually have not just one, but multiple map overlays that can help you with your flight planning. So for example, now, as you can see, we have this large orthophoto. And if you have some other map, so here, this is a map overlay of a magnetic survey that we did over this test range. And I can also now import this in here. And so now you can, of course, see that we have three map layers. We have the base layer, we have then the large orthophoto, and then on top of that, we have layered our magnetic map. And of course, if you want, you can, have the other orthophoto as well. But yeah, so in this case, I'll just be using these two. So yeah, this is one thing that's quite useful when you're planning your missions, since the map can be adjustable. And now let's go into the terrain elevation tab. So let's go in here. And so actually GCS also does come with terrain elevation models. So by default, GCS is using SRTM 1 arcsecond data. It is split between north of 60 degrees latitude and south of 60 degrees latitude for the rest of the Earth. So you have these two layers. For those of you who are located in the United States, we do have the USGS, again, not to be confused with UGCS. But yeah, we have the USGS 1/3 arcsecond elevation data that's also available here by default. So this has 3 times higher resolution than this 1 arcsecond, and you can easily enable it by simply dragging this in here. And then now we can also click on this focus button, and now you can see that this covers the United States, and in case you're flying in Alaska, then also we have a separate layer for Alaska. Now, Also here, you can, of course, import your own elevation models, which is quite important, especially when you are doing LiDAR surveys. So if you're flying at a high altitude where over a place where the terrain isn't changing much, then this may not be as relevant. So probably even the default data will be good enough. But very often, especially when you have this data available to you, you kind of want to use the best elevation model you have because it will simply give you the best end results that you can get. So in here, I have already uploaded data from, it's also from USGS, but I just loaded it so I can show you an example. So now let's click here to focus. And so currently I loaded this actually as a DSM. And so you probably know this already, but so difference is that for the DTM, this is what is used for the for determining the altitude of the drones. This is simply the terrain model without any vegetation, without any objects, any buildings on top of that. Now the DSM, this is what usually contains also information about the vegetation, so trees, buildings, etc. So UGCS actually does support both. So here for now, even though this is an elevation model for the terrain, I just loaded it in the DSM tab just to show you. But so typically you would be loading it in here in the DTM, and then also you, with this method, you can get also higher accuracy. So now let me maybe just so I can demonstrate. So in here, you can currently see that this is already with the higher accuracy data. Now, if we default to the, let's maybe use, for instance, this one, just so I can demonstrate to you the difference in this. So now we're simply using SRTM for data. And so here you can see that this, for instance, this little bump over the hill. So here, this is not visible in this data simply because the resolution is too low. And now if we, of course, load our higher resolution DEM, then, of course, we can see way more detail here, which, again, it will not only allow us to get better data. As a result, it also does increase the flight safety of the mission. So yeah, it's also quite important. And it's just well, part of the process of flight planning that you just need to be aware of if you are flying in areas where the elevation is changing a lot. And I know that a lot of our users are in such situations. So this is how you can load a DEM. And to add it, it's very simple. You just click here on the plus button. You can add some name for it, create it, and then you can simply click on upload the data, choose the GeoTIFF file, and then simply drag it here in this section, and you're done. So that's about that. Now I think maybe I'll quickly go through a few other things which you can do in the map layers, and then we'll go into the flight planning itself. So you have the 3D objects here. That's for any buildings that you want to import. Although, yeah, building models actually are not really used that commonly, since those are the KMZ models. Now, next is 2D objects. So here you can import KML files. This is useful if you are, for instance, doing power line scans with LiDAR. Then if you have KML locations of these power line towers or even the lines themselves, then you can also import this into UGCS. And these lines can even be displayed in 3 dimensions, meaning that they can, of course, also, you can see how they are changing the height, and then you can use them as a point of reference when planning your missions. Next is the place marks. So place marks also you can create yourself anywhere on the map, and you can also import them. So they're simply, location markers that you can use to, for instance, identify certain places, and you can add some description to these as well. So quite simple. Next, we have no-fly zones. So here you can simply enable or disable them. Custom no-fly zones you can create down here. And next is the offline maps. So in case you are flying in some area where you may not have internet, or maybe the connection might be limited, so then also UGCS does allow you to cache maps and elevation for offline use. To do that, you can simply right-click anywhere here on the map. You can select offline map. Then you can mark out the map region that you want to fly over. Again, enter some name for it. You can choose exactly which map you want to cache and which elevation sources. Then you can click on create, and then this will be cached for offline use. So that's about that. I'll see maybe there are any questions I can answer. Okay, so from David, there's questions. So is it possible to control the layer opacity on the map? Unfortunately, no. So from the interface, you can't really control the opacity, but interesting suggestion. Actually, maybe we should consider this. Um, okay, and also from Robert, there's questions. So what do you recommend in steep terrain for LiDAR flight planning? Um, I think now when we'll get into the flight plans, I'll try to maybe talk about some points. But in general, when you're flying over very steep terrain, I think it's a good idea to use, for instance, the smart AGL flight altitude algorithm that we have inbuilt in UGCS, which also can make your flights a bit safer. But there are some caveats with this as well. So I'll try to cover all of this. So again, just an ask in case you have some questions, please do put them in the Q&A so I can also try to answer. Oh, okay. Another one I see is how do 2D objects work? Okay, I suppose I maybe should cover it in slightly more detail. So essentially, 2D objects, these are KML lines, right? So I'll try to give you a very basic example, and actually with that, I guess I can create the first route for today. So maybe let's start off fresh. So I'll just click on create new mission. Now I'll click on create a new route, and then simply I'll create a new route from scratch. By the way, you can also import routes from files, so from CSV and KML files, and even existing GCS routes, you can also easily move between computers using this import from file. But anyways, now we will create it from scratch. Now let's maybe take the DJI M300 as the drone for this initial example. Now, you can see I have the waypoint planning tool selected, which is, of course, the most basic one. Now, I'll just create a very basic route here in UGCS, so just a few waypoints. And let's see, it might give us an error for the distance. No, actually, it's fine in this case. So, question was, what are 2D objects? How are these used? So we can imagine that maybe this route right here, these are power line towers, right? And usually you have already some existing KML data set. This might come from either from your own company that you have created or from some customer. But anyways, typically there are some either boundaries or some power line tower locations, something like that. So now I'll just, again, here I am kind of just creating the KML file myself, but usually you would already have the file pre-made, right? So now let's go through here. I'll just export this as a KML. Now, the altitude, there's two options. You can either set it relative to ground, which means it will be planted on the ground, or you can set this as AMSL, so above median sea level, which will mean that this altitude will be set, well, this will be in 3 dimensions, basically, meaning that the waypoint height will be the exact height of the KML line. Then here there's also two options, either as place marks or as line string. In this case, I'll use line string so that it will be a proper to the object instead of being place marks. Now let's click next. Let's export this. I have my folder sample data over here, and then I'll just save it over here. So again, this is just me creating it. Usually, like I said, you would have it. Now we can go here into map layers window again. By the way, this route I will just close. Then we can go into 2D objects. Now I'll just create this object one. Now I'll upload the data. So this will be the same KML file, which I just now created. And now this I will move into the active layers. And then simply here, you can see that I have this line visible here on the map. Now, lines like this you can use as a point of reference. You can ensure that, for instance, the altitude, so the AMSL altitude of the flight you're planning will be safe. You can also ensure that, for instance, the drone will be correctly positioned over this center line, and you can even create missions from this. And I think actually, why don't we do exactly that? So now we have this one KML file that we can imagine it, let's say it's a power line corridor that we need to scan. So what are the next steps? How do we create it? In general, there's two ways. So either you can create a corridor from scratch, or you can import it using this file. So now I'll click here on create a new route. And then in this case, I'll just firstly demonstrate how you can import it from a file. So I'll just hit browse. I'll again select the same file. And so then over here, by the way, yeah, so here we can select which segment we want to use. So since if we would be importing a KML polygon, so kind of a closed figure, then we can choose one of these. But since this is a linear segment, then I'll select LiDAR corridor, since obviously today's webinar is about LiDAR, and in this example, we are imagining doing a mission for power lines. Now let's click next, then we can choose our drone. I'll just use the trusty M300. And so you can see that actually now UGCS did put these points exactly where we had the approximating points of the KML. So now using this, we have our corridor. But of course, as you may see, this is not yet complete because we do need to add a few parameters here to our route. So firstly, we have the field of view value. This is for the LiDAR sensor. So depending on which sensor you are using, this field of view value will be slightly different. But kind of as a general rule of thumb, I suppose for DJI LiDARs, this is 70 degrees. So I will use 70 for this example, but of course this you set based on what sensor you have and what is that sensor's field of view. Now, next is the flight height. So here, again, I'll just set the flight height to 50 meters. It's quite standard, I would say. Then the flight speed, let's set to 8. And then there's also the side overlap. And so this we can set to, for instance, something like 20%. But for the corridor, actually, you can also play around with the width parameter because this also allows you to set how many lines you want in the corridor. So right now you can see we have simply one line here. So the corridor goes just in one direction. In case you want the drone to scan this location from two sides, so going there and going back, kind of following the center line, then what we can do is we can simply increase this width parameter, and at some point it will also, yeah, so now you can see with the width parameter set to 80, this will give us 2 lines. In case maybe you wanted to do even more lines, this can, I suppose, be more the case for when you're maybe doing some planning for construction work. Maybe there's some new road that's being built and you really need to have a more wider corridor. Then you can simply set the width to how you need. And then, for instance, here you can see we have 3 lines, and then we can set this even larger. So now I think it should be 4 or 5. Yeah, now it's 4 lines. Well, I suppose you get the general idea. So now there's a few more parameters in here that I want to go through. But firstly, so I'll go back a bit to what I was telling you in the very beginning in the presentation. This was about the measurement units, and I just want to also demonstrate how you can switch them, because from time to time we actually do get these questions on how do I switch from metric to imperial? How do I do that? So this is all done in the main menu of UGCS. So to go there, you simply need to click up here in the top left, then go into the main menu, then under configuration and measurement. So this is now where you have this measurement unit switcher. So if you're using metric system, you can just select metric. If you're using imperial, you can set this. Or if you want to make some more adjustments, then you can also go here into custom, where, for instance, you can set the distance to metric, the altitude, let's say imperial, speed. Also here you can see we have now these even aviation units. So you can play around with this and set this up exactly how you want to. But for me, since I'm from Europe, I'll be using metric system for this workshop, for these examples. Now, we have our LiDAR corridor. And what's also really important is that usually this will depend on what LiDAR you are using. You will need to do IMU calibration. This is highly important for LiDAR sensors because this ensures that the LiDAR's IMU is working correctly and gathering correct data, and that there's no error in there. So this will then depend on what sensor you have. For DJI LiDARs, there is one approach. Then for many others, there are 2 different ones. In general, in GCS, there's 3 main approaches to LiDAR IMU sensor calibration. Now, let's start off with number 1. This is for DJI LiDARs. Yeah. So if you have something like the L2, the L3, L1, so this will apply to those. Yeah. Okay. So firstly, we need to select our camera in here. So then as the camera, of course, we will be selecting the DJI LiDAR. So in this case, since this is an M300 and it does not support the L3, I will simply select the L2 LiDAR. Now, after selecting it, you may have noticed that at the beginning, so here, and at the end, so over here, we have now these blue segments. So these are actually the same calibration segments that you would see in DJI Pilot 2 application, and this will simply move the drone back and forth to calibrate the IMU. Now, if you are planning a longer mission or a larger area, for instance, where you might have some segments where the drone's flying, on a straight line without moving for a long time, then there also will be calibration segments added in the middle. Maybe now I'll try to give you a quick example of this. Now, with this, actually, I'll just try to plan now an area scan where I'll show to you how this is done. So now I'll just create a new route from scratch. Again, I'll be using the M300. Let's select LiDAR and let's select area. Now, let's say maybe we need to scan with LiDAR this suburban area here. Now I'll just mark out the approximate location of what I want to scan. Hit enter to complete. Now also you might see this message that says if you want to get a colorized point cloud, make sure to add this set camera by distance action. So that's also important. Now I'll just remove this direction angle to ensure that these lines are most efficient. And now let's go again here in these parameters. And for the camera, again, I'll select the L2. Now, we should see, so here we actually have this. So of course the calibrations at the beginning and at the end. And usually when you have a longer line where the drone is flying without stopping, then also you will see these calibrations here in the middle. So now let me just kind of try to drag this out a bit and then maybe, yeah, so now you can actually see what I wanted to demonstrate. So when you have these longer lines where the drone kind of is flying without any waypoints in the middle, without any altitude or kind of changes to its gyros. So then here you can see that the software does add these IMU calibration segments in here in the middle, just to ensure that the IMU works as expected. And this behavior is the same as what you would see in the DJI Pilot 2 app. So this is the same for the L2, the L3, and for the L1, since it has to be calibrated a bit more often, then also it does add these segments slightly more often than for the L2. So in general, that's how you do it for the DJI LiDARs, and you have to ensure that this IMU calibration checkbox is enabled. So this is what actually adds these points. And so this checkbox, this is just for the DJI LiDARs. In case for some reason you don't want the drone to do the calibration, so maybe you prefer to calibrate it at the beginning from the controller, then you can uncheck this. But then as you can see, so these calibration segments are removed. Now I'll click this again just to ensure that the calibrations are here. And now if we go into actions, so you might remember that it did ask us to also add the set camera by distance. And now you can simply add this in here. And you can see that now we have actually two actions for this route. So firstly, we have set camera attitude. This will simply change the angle of our L2 to 90 degrees downwards. And the next one is set camera by distance, which will, of course, trigger the camera to ensure that we are getting a colorized point cloud at the end. So because for DJI LiDARs, it's a bit more specific case because there you have to trigger the camera from the software because it's all interconnected, so to say. But for most other LiDARs, so I know that there you simply turn it on and then it starts working automatically, starts taking the pictures, starts doing the scan. So for other LiDARs, usually you do not need to enable this separately. So you might have some cases, maybe you're even using two separate sensors, so one camera and one LiDAR doing separate flights. That's also possible with the GCS, so any flight plan you can modify like that. But yeah, so usually this is how you do for DJI LiDARs, and now we'll jump into also how you can do for other types of LiDAR sensors. Before we get there, I'll just quickly take a look at the Q&A and then see what... Maybe there's some questions I can already answer. Oh yeah, so one question is, so do you have any recommendations for setting the field of view for LiDAR units with 360-degree scanning? There, it's quite simple, I would say. You can simply set this as 360 degrees. So If you go here for the field of view, then you can also set this as 360, and then the mission will be, sorry. Yeah, so actually, that's my mistake. So the maximum one here, it's indeed 180. I would also, let's see, what's that? I suppose it wants 179 as the maximum, most likely. Yep, that's good. So now you can see the line spacing is slightly adjusted, since actually that's what the field of view is for. Since when you have this side overlap, then it's using this field of view angle to also determine what should be the side overlap between the flight lines. It's also possible to, by the way, set the side distance in meters. Well, set it explicitly in whatever measurement unit you are using. In general, I'd say that the field of view angle also, it can depend on the drone model that you're using, since of course you also might want to set the field of view angle so that, maybe the drone landing gear is not really in the way. Depending on how the sensor is placed, what drone you're using, and so on. But yeah, in general, so as you can see, so here the maximum value you can enter is 179 degrees. So I suppose if you're using a LiDAR with 360 degrees field of view, you can simply set this to 179. But I would say that even like using standard 70-degree angle, it's a decent approach, because you will still have more than sufficient overlap, since of course your LiDAR's field of view angle is even higher. So now that's about that. And now I'll just, before we jump into doing some other LiDAR IMU calibrations for other sensors, I'll just kind of try to kind of go through these parameters and what can you set here. By the way, also, I'll just open up the elevation profile. So this can be opened from the top bar here. Let me try to also expand this for you. And also this is quite important, because this does allow you to see, so where will the drone exactly be with respect to the elevation profile. So you can see any inclines that are here. You can see the exact altitude at each point, and if maybe there are some more dangerous parts of the route that you might want to adjust before flight, or you might want to investigate, then you can take a more in-depth look here. For instance, here you can see that at this point the drone is flying up a hill, and of course here you would also expect that there may be some vegetation here as well, and so you might want to be a bit more careful when flying in this area. Now, let's go back here to our parameters and let's see what else can you adjust. So firstly, we have this forward overlap. That is for the camera triggering specifically. So this will determine, if we're using DJI LiDAR, how often will the camera be triggered. For other LiDARs, this forward overlap is not really an important parameter. Now, next is the corner radius. So you can see this default one is set to 6 meters. And if you increase this to, for example, something like 20 meters, then also you might notice that now once the route is recalculated, these corners over here, they are kind of smoothened out to ensure that the drone can corner smoothly without any kind of more those jerky movements. Next, also we have the loop turns, which can be useful sometimes when the drone has some more sharper turn, although in this route I don't really see them. So to save battery, I would just, at least for now, suggest to not use them in this particular route. This can be useful when flying some tighter corridors, and then you can set the drone so that instead of it simply turning, it does the loop and then proceeds to the next flight line. Now, we have also our turn type. So in this case, this is set to adaptive bank turn, which is the standard recommendation for DJI drones when doing these missions. For other drones, there will be other options. So for instance, if we're using a drone based on autopilot system, then also in this case, you can set it either straight or spline turn. Now for the altitude mode, right now, you can see I'm using the Smart AGL altitude. And also, I'll just kind of now explain to you a bit the differences between normal AGL and Smart AGL. So for the most part, they are very similar. However, the differences will be visible when the drone is flying up a slope, up a hill. So the AGL, what it does is it simply checks that the distance between the drone and the ground will be set to what you have set here. So the flight height will be 50 meters. And you may see now that also as I'm moving the cursor through, you can see that this altitude will be roughly 50 meters even when flying here. But now you have to also take into consideration that when you're flying up more steep inclines, then even though this distance below the drone might be set at 50 meters, but distance between the drone and what's in front of it, it might get a bit too uncomfortably close. So if you want to ensure that this will be safer, what you can do is you can select the Smart AGL mode. Now with the Smart AGL, the drone will keep a safer distance, not just to what's in front of it, not just to what's below it, but also to what's in front of it, thereby, making also the flights safer. So now that's about that. If we go here in the advanced parameters, there's a few more kind of tweaks we can do for these missions. So firstly, we have the AGL tolerance parameter. With this, you can adjust the resolution of the terrain following. If it's at 3 meters, in this example, the software will set waypoints if the elevation changes by more than 3 meters. Now, if I was to set this to 10 meters, for example, now you might notice that we have less waypoints and the route is a bit more jagged, so to say. But yeah, now at the same time, if maybe you don't want the drone to do as many adjustments to the altitude, then also this is what you can use. And vice versa, if you want the drone to adjust its altitude more often, and this can also be useful when flying up steep inclines, when you're using a high resolution DEM, then you can also set the AGL tolerance, for example, to 1 meter. And then also you might now notice that even though there's more waypoints in this route, but now, for instance, when we have these inclines over here, then actually the drone is following the terrain more closely. And yeah, so now this is also what you can do, especially if you're using a high resolution DEM. This can be very useful to also increase the flight safety. Now, what's more is in some cases, you might want to scan slightly over these lines, because as you may know, so of course, when the drone with LiDAR is turning, then in those turns, usually the data is not very good, right? So if you want to change, or if you want to kind of prolong these flight lines slightly, you can use the overshoot parameter. So with the overshoot, let me now set this to, for example, 50 meters. So now you can see that actually these turns, they are now set outside of our area. So now the drone turns outside of that, and this ensures that once the drone gets back on the survey line, that the data collected will again be good, and that within this selected polygon, you'll get good data. And also, in case maybe you want to extend it, not just kind of, in case you want to extend not just the survey lines, but the whole area, for that you can actually use this area buffer. So if you add this area buffer, then what will happen is you may now notice that the flight lines actually will overextend over the whole area, like so. So now this is just one way, for instance, if you're flying some larger projects and you want there to be some overlap between all the areas in the project, this is one of the things that you also can do. And yep, there's also the trajectory smoothing. This is more used for magnetic surveys, but for LiDAR as well, if there's maybe some areas where you don't want the drone to fly into, that you want to skip over, and you want to adjust the slope angle. Also then what you can do here is, for instance, we can set the slope angle, let's say to 10%. And also you may now notice that in some parts now the drone is flying at a straight line rather than following too closely, and it's also keeping a safer distance to the terrain that's there. In case you want the drone to maybe skip over some areas, then also there's the minimal gap parameter. So this also, for instance, we can set to something like 200 meters. And now you might notice that there's kind of some plateaus where the drone is flying, where it kind of does skip over those areas without flying into those smaller gaps. So it's also just one part of this tool set that you can utilize. And again, so these are a bit more advanced parameters, but these can be very useful when you're planning your missions. And so GCS does give you a lot of this adjustability when it comes to the altitude and exactly how the drone is flying. So, and that's about that. Sorry for maybe talking a bit too much on this topic. But now I want to also show you how you can plan out area scans for LiDAR, not only for DJI LiDARs, but for other LiDAR sensors as well. Since I know many of you are using LiDARs such as Regal, YellowScan, Robotic, and many other great sensors. So now let me again create a new route. Again, just for this example, I'll be using, actually, I'll not be using the M300. Let's maybe take some other drone from our list. So let's maybe take Inspired Flight IF800 drone. So again, let's do LiDAR, let's do LiDAR area. And now again, I'll just maybe plan out quick area over here. Okay, and yep, so now I might need to set this on a direction angle as automatic. So now let's just wait for this. Okay, so here you might notice it shows that the fence radius has to be changed. So for some drones, the fence radius is slightly smaller. And in case you see this message, don't worry, you can just click here and then this changes the fence radius in the drone profile. So for example, we can set this to, let's say, 5 kilometers, and then now this will be adjusted. So now let's set, so I'll set this field of view, for instance, like so. Yeah, flight height, let's set, let's just keep this as 50 meters. I think I'll remove the area buffer and the overshoots, just not to maybe have too many parameters. Since actually here, the main thing I want to show is the IMU calibration. So I just want to have the whole mission quite simple. So let's set this to even normal AGL. Okay, so there we have our basic initial mission. So now, based on what LiDAR you are using, you need to use a different IMU calibration pattern. So I showed you how you can use this for DJI LiDARs, but if you're using something else, then you might have to use one of our other inbuilt LiDAR calibration tools. We have two others that you can use. So typically, and the one that has been kind of in GCS, the longest is the figure 8 calibration pattern. So for most LiDARs like Robotic and many others, these are good LiDAR calibration patterns to use. So typically, you would add this to the route. So you can already have it inside of the route when you're planning your mission. Now let me just select it. I'll add it here on the map. And also, by the way, you can see that to whichever corner you place it closest to, that's from where the route also will start. I'll just need to move this also here to the very beginning. And now you can see, so this is how it looks like. So we have very simple figure 8. Here also you can change parameters such as the flight speed, you can change the size. So for instance, the speed, let's set something like even 15 meters per second. And then of course also in case you want to make it slightly larger, you can. So for instance, let's maybe set this to something like 80 and 40, just for the sake of the the example. Okay, so now we have our initial figure 8 calibration where the drone will fly in the figure of 8. You can also adjust how many passes you want the drone to do. And then once it's done with that, it can proceed on the mission. And then at the end, after the area, you can also have the same figure 8. This will depend slightly on which IMU, on which LiDAR you're using. For some, it's required to do this both at the beginning and at the end. I would say that's the most common one. But for some, I've heard that also it's okay to just do it at the very beginning and there's no need to do it at the end. But I think usually the case is both at the beginning and the end, you need to do the calibration. And so this is how it looks like. There are some cases when, especially when you're flying larger missions, that you might need to do the calibration at like when you're starting out, and then you might want to change the battery in the middle. And so how do you do the calibration there, right? Common question. So now I'll just kind of demonstrate. So you can actually create a separate route with only the pattern calibration. So for instance, I can just add this in here. I'll just add a bit here to the side so it's more visible. It's a separate route. And yeah, so now what you can do is if you, for instance, if you have covered some part of this route and you need to resume, so then what you can do is you can simply firstly upload this separate pattern route. You can have the drone fly this, and then when the drone has done that calibration, you can simply upload this route from an exact point. So for instance, this one, and this, by the way, just to maybe demonstrate how it's done, when you have the drone connected. This will depend, also change in how you have it connected and which drone you're using. But so for the most part, you will have a very similar looking telemetry display. And then when you just want to upload the route, you upload it. Here, it will ask me now to set the profile because this is just an emulator drone. But then you'll have 4 options here, and also one of them will be to basically start the route from an exact waypoint. Maybe I'll try to show you quickly. So here I'll just now set the oh, but yeah, sorry. I think now for the emulator, I'll need to quickly probably replan this area because yeah, the emulator drone is oh yeah. So for the emulator, the LiDAR area isn't really available. Yeah, so that's a bit my bad. Sorry about that. But I'll just quickly now maybe replan this. Let's again go for the some of the normal drone models like the IF800. And because anyways, I now also want to show how you can calibrate LiDAR sensors, not just using the figure eight, but also how you can do this for YellowScan LiDARs. So now we have our area. Let's maybe make a few more adjustments over here. And then also I'll just add the figure eight calibration. So let's add one here, like so. Okay, and now just I'll add also one at the end of the route. So now this is how we had it. Okay, so now where I was. So yeah, basically when you're uploading the route, then here if you're doing this directly from your GCS, then you have the options to either continue the route from where the drone left off, or you can start it from an exact waypoint, which also allows you to ensure that, for instance, one survey line, if you're interrupting it in the middle, you can just cover it again, just to ensure that you don't have any data gaps. That's also, I would say, quite important. Yep, so that's about that. And then also, if we're using a YellowScan LiDAR, then instead of doing the figure eight calibration, it's recommended to do the U-shape / J-hook calibration pattern. So now to do that, what I can do, I'll also show you one interesting thing here, is I can just duplicate this whole route. So now I'll have the new route over here. And now this whole thing I can just select. And now I can also, for instance, just move it here, just so we can have it adjacent to one another. Now, I'll just quickly remove both of these patterns. So I'll just select the figure eight, one of them, remove, do the same with the other. And now I can add the U-shape calibration. So now, again, process is exactly the same. So I just select the U-shape, click here on the map to add it, make sure that's at the beginning, and then over here also I can add the U-shape calibration. But again, what I'm showing now, it's a very simple example, but this is something which you can use even for larger projects. So you can ensure that every time you calibrate the IMU, this will be consistent and that you will get a good outcome from this. And yep, so that's actually, those are, I would say, the main 3 ways. So again, number 1, what I showed is for the DJI LiDAR. So kind of, again, I suppose this is a bit of a summary, but yeah, so here it's quite simple. Simply ensure you have this camera set as the DJI LiDAR that you're using. Ensure you have this IMU calibration checkbox. And then in the route, you will see these blue parts, which will be the IMU calibration points. And then simply when you have either your DJI drone connected to GCS, or you can also, by the way, sync these routes automatically to your Pilot 2. So during the flight, you can just use normal Pilot 2 interface and the GCS routes. Then these same calibrations will be done. Now, for drones that require figure eight, again, very simple. You have your LiDAR area and you have the figure eight calibration patterns. And then for YellowScan LiDARs, then you will also now have these U-shaped J-hook calibration patterns, which you can add. In these patterns, what the drone does is it firstly flies with, basically maximum speed forwards, then brakes, backwards, and then on the third time when it flies forwards here, it goes through the loop, and then the calibration is done, and the drone can be on its way to collect the data. Okay, so that's for the most part it. I also did show the corridor, so the corridor and the area. Now I'd say, let me check if there's maybe some questions. What I can try to answer. There are probably a few, and let's see. Okay, so one is it possible to set the focus and camera dewarping in the planning settings? No, so the focus and dewarping, it can't be set on the planning part. But I know sometimes this dewarping, it's done when you are already processing the data, so it's kind of done more on the processing stage. Um, then next question is, does this also work for a DJI Air 3S? And so, yeah, the Air 3S, it's more of a consumer grade drone, and unfortunately, so you can't really do LiDAR surveys with it. And also, since it's not really supported in DJI MSDK, we also can't support this drone fully. But I know that for many of these smaller DJI drones, so you can still do photogrammetry missions with them, but it can be a bit more tricky. There are some that are supported in DJI's SDK, such as the Mini 4 Pro, which we also support, and for this you can do the flights directly. But for some drones like the DJI Air series, so for these, one workaround, again, it's not really official, is that you can do the flight plan, and then since the remote controller, so DJI Fly app will save a KMZ file, then you can replace that KMZ file from a file with UGCS or some other planner. But again, it's a bit unofficial way and requires a bit of technical know-how on how to exactly replace the files. Okay, so from Robert, I see this question. So will with DJI M300 and L2, I have to upload the route still via DJI app in the RC? Okay, so for the M300, you actually have a few options of what you can do, and depends how you have connected this drone to GCS. So in general, first option is you can use our own app. So it's available on our website. I'll show to you in a second. With this method, you can upload the route directly from UGCS. So that means if for the M300 you're using either the UGCS companion app or UGCS for DJI, which is for older drones, but it also includes the M300, then you can have access to all of these actions here to upload the route, start it, and so on. In case you prefer to use the Pilot 2, you can also do that. So we do support route sync to Pilot 2. This can be done by opening up this connect from Pilot 2. And there's here two options actually. One is using the local network. So you just connect the controller and computer on the same network, and then you can connect directly to Pilot 2. Other option is using UGCS Cloud. So with UGCS Cloud connection, using this, you can also connect and, well, basically synchronize the route. But with this, you will not get telemetry. But in general, there's different ways of how you can get the route from GCS onto your DJI drone. Depends which way you prefer, whether you prefer to use the Pilot 2 application or whether you want to use our own application, have the possibility to use these commands here. Okay, now yeah, another question from Jeremiah. When using the L3 sensor, we found that when we use the IME calibration, there is nothing added to the route. Could this be because we have a small area and it does not do enough turns? Yes, I think you are very much on point there. So this is exactly why I expanded this area. And that's also, by the way, how it works in Pilot 2 application. So if you have a very small area, or an area where the drone is doing a lot of these altitude adjustments, so then the calibrations are not really needed because the drone is moving around enough. The calibrations here are needed when the drone is flying on some longer segments without adjusting too much, and then kind of the IMU can, as we call it, fall asleep. And in those cases, you need to have the calibrations. But yeah, so of course, if you're flying a smaller area, so I'll just now quickly try to decrease the size. So then you'll probably see that the calibrations are only set at the beginning and the end. So in this example also, now you can see I have this calibration. This is at the end of the route. That's the beginning. So there you have these blue parts, but there's nothing here in the middle. And that's completely normal. So no worries about that. So for smaller missions, that is what you will see. Okay, next question from Oscar. Where does it show the length of time for the mission when the calibration is added? So the length of time is shown here. So in the elevation profile, so this is the estimated time of the route. So here you can see this is currently for this route 33 minutes and 43 seconds. So this is always here in the elevation profile. This is where you are able to see it. Okay, next question. So, when flying from flat to steep terrain, is there a recommendation or possibility for reducing speed? Also, great question. And this is actually done automatically by EGCS. And I'll maybe try to now explain a bit how it exactly works. So, and now let's say we have this route. We can also see the elevation profile that's here, which is actually, even though it's suburbs, it's quite, I would say, mountainous suburbs. So in here, what UGCS does is that it does always check what's the maximum descent and ascent speed. So firstly, for each drone, you have the drone's profile. Let's take as an example the M300 that's here. And now, if we go here on edit, you will see that there is this maximum climb rate and maximum descent rate. Now, what the GCS will do is if it detects that this elevation change in the route will make the drone exceed this allowed climb rate, then it will actually slow the drone down. And you will see some notifications of this in the route log. And actually, let's go back and see, because maybe it already did that for this particular route. Now, let's maybe take this example with the IF800, and now we can see here. And yeah, so actually, you can see these messages here, right? So it says segment 2, which is the LiDAR area segment. So vehicle speed will be reduced from 6 meters to 5 meters due to speed constraints in the vehicle profile. Maximum climb rate exceeded. So exactly at those points, the drone will fly slower. So it will probably be, I'm guessing, over here. And now if I set the agile tolerance even less, probably you might see, okay, there's not more messages of that. Oh, I think that's because of this minimum gap parameters. Now let's see. Okay. Well, anyways, so part of this is done automatically, right? So this is what the software handles based on those maximum ascent and descent speeds. Now, what else can you do? So you can also actually make some of these changes manually. So I'll also show you a bit on how you can exactly do that. So, for example, any route in EGCS, if you want to make more kind of those fine-tuned adjustments, any route can be converted into waypoints. So now I'll just convert this route into waypoints. And now you can see, for example, that here, when the drone, before it is flying up, you can see, so currently here, this speed is set at 6 meters per second. Now, if you wanted the drone to fly slower in these exact parts, then actually what you can do is you can simply, mark out all these waypoints where you want the drone to fly slower, and simply, for instance, set the flight speed to something like 3 meters per second. So that's also one of the things which you can do if, in case you want to, make those kind of more detailed adjustments. Okay, then another question from Jeff. Please, can you show the drop-down menu for supported LiDAR cameras? Okay, so here I'll just explain a bit about LiDAR sensors and cameras and how this is different. So for normal drone cameras, and let's maybe take as an example let's go to one of the routes that we have. So you might also, by the way, have noticed that here, when I was planning this mission, again, this is for non-DJI LiDARs. Then I didn't select any camera that's here, right? So there's this Centera camera, but this is just one of the default cameras for IF800. So since most of these non-DJI LiDARs, they come with their own inbuilt cameras. So actually there, you don't really need to select the camera here. And you might ask why. That's because these flights, they're planned using the field of view angle, and the cameras here, they're mainly just used not for photogrammetry purposes, but for the purposes of, simply using getting a colorized point cloud at the end, right? So then that's why you don't really need to have the camera, because the camera, it's basically being used to when you set the forward overlap and when you set actions such as set camera by distance, right? Because then it takes that camera's frame, it calculates, how often should the camera be triggered, and it adds this action there automatically. Now, since the camera is part of the LiDAR system, then you don't really need to do that. What you can do is if you want the images to have a bit more overlap, you can play around with this overlap parameter and, for instance, set this higher so that the flight lines will be closer to one another. But yeah, so in short, there's no exact list of LiDAR sensors, and that's because basically all LiDAR sensors on the market that you can put on a drone, these you can use with GCS, simply because it's very universal and there's no need to select the cameras separately. So I hope I answered that. Um, so sorry, Etienne, there a question like for a cliff, up and down or left and right. Sorry, this I don't understand. Maybe you could rewrite it slightly. Okay, also another interesting question. So, does GCS support multi-drone operations where two drones can be assigned to different routes and flown simultaneously? Great question. Answer is yes. So with GCS, you can actually fly multiple drones simultaneously. So here you can see now on the screen, I have just the one emulator drone, right? Just to kind of show you how it looks like when you have a drone connected. But what you can do now, I'll just add the second drone, right? And so, of course, the drones, maybe I'll just quickly jump to where they are because they're in a bit different location, but just so you can see how the drone models look as well, right? And of course, when they're flying, also you'll see how the drone's following the route and so on. And yeah, basically, I mean, you can coordinate multiple drones at the same time. So with standard GCS licenses, so with Pro and Expert, you can have up to 3 drones connected simultaneously. In case you want to have more than 3 drones, then you need to have the enterprise license. Or if you want to, well, basically send commands to drones, to multiple drones at the same time. So, for instance, let's say maybe you want to take off with 10 or even 12 drones and you want to upload all of the assigned routes to them. Then we also have GCS Commander application. It's primarily used actually for counter drone testing. So for testing counter drone systems where you need to ensure that, multiple drones are moving towards some target and that, the systems can detect all of these approaching drones. So that's actually kind of designed a bit for that. And there you can assign routes and you can have one drone flying one route, another one flying another one. But kind of for more, I would say, standard case for more standard LiDAR surveying, what you can do is you can, for instance, have one drone take off. You can have this drone start the LiDAR route, let's say from the middle, and then you can have another drone start the route from the very beginning. And that's how also you can have multiple drones in the air at the same time. You will also see here the indicators for the battery, for the GPS. You'll see the drone's locations on the map. So, yeah, UGCS actually, it fully supports those multi-drone scenarios. So, yeah, thank you for asking. It's a great question. Glad I was able to cover. Okay, so from Jeffrey, the question for DJI Zenmuse LiDAR, you mentioned 2 actions to set. Could you cover those again? Yes, absolutely. So let me go back. Let's see which route this was. I believe this route 2. Okay, so now this is the route for the that I planned for the DJI LiDAR. And so here you can see there's 2 actions. Actually, one of them is added by default always. This is this set camera attitude. So here you can simply see I have the tilt angle set to 90 degrees, but you will see automatically here. There's no need to add this manually. This will be here. So this will simply ensure that the camera will be facing downwards. In this case, let's say the DJI L2 camera. And then next is if you want to get a colorized point cloud, you simply need to add this set camera by distance action. There's 2 options. You can either set the camera by time or set it by distance. If you want to see some more details on how often will the camera be triggered, then in the route card here, you can click on this green checkbox. And then you might notice that here it tells you what's the total area, what's the size, how many waypoints, how many passes, and for the camera triggering, you will see how many shots will be taken and what is the interval. In this case, the interval is every 11 meters, the drone's camera will take an image. So I hope that this answers that. So in short, when you're planning DJI LiDAR missions, kind of to summarize, you just have to select the correct LiDAR sensor, either the L1 or the L2 or L3, depending on which one you're using. And for the actions, ensure you have the set camera attitude and set camera by distance. Okay, so then, okay, let's see another question. Has the GCS app added the availability or ability to resume the flight from previous location after you called home for a battery swap. Yeah, from GCS applications. So, for instance, the companion app, there is the possibility to resume the route. So this you can do. And also, of course, so in general, there's two ways. Either you can, this is more from desktop, that you can set an exact waypoint from where you want to start, or you can simply resume the flight. Okay. You can see another question. This is about the Astro drone, so the free fly Astro. So you're saying that, yeah, when you use the figure eight with the Astro, the drone will kind of a bit stutter in the waypoints rather than flying smooth. This we have encountered specifically for some Astros that they do fly like that. That yeah, they do kind of stutter at waypoints. It's kind of simply due to the drone's behavior. So this will change based on what drone you're using. If I know for some PX4 drones, that's an issue. Autopilot-based drones, they tend to fly the pattern figure better, so they tend to fly that without stopping. You might want to also try, maybe in your case with the Astro, doing the U-shape calibration, because in general, from what I've also spoken with some IMU manufacturers, there isn't really a big of a difference as maybe some of those who sell the lidars say on which pattern to do. So in general, as long as the IMU is woken up, as long as it's kind of shaken up, so to say, then it should be good. So my guess is that most likely you can also try to do the U-shape. The Astro might be a bit better at that since it would, calibrate the IMU by flying forward and backward rapidly. So yeah, in case you maybe have issues with pattern 8, you can try to do the U-shape and see if that gives maybe some better results. Okay, so let's see if there's anything else. What's the recommendation for side overlap with the L2 height-wise? That's from Benji question. Will you support flying at 90 meters? Yeah, there's no really restriction in GCS as to how high you can fly. So here you can see that for this LiDAR area, I set the flight height to 50 meters. You can also set this to 90 meters. Then, of course, then the side overlap will also be adjusted. You have to take into consideration what will be the point density. Oh, here actually it says, yeah, can't fly over. I think this might be, let me change it here to AGL and let's see what is the issue here? That's interesting. Let me see. I'm now curious what it doesn't like. Because sometimes especially when you're using maybe the trajectory smoothing, you might have some, yeah, I think this was because of that. And now with all of this, now this seems to be good. Now let's see, should calculate. Okay, maybe also because I had the AGL tolerance set quite high. Although no, I don't think it's because of that. But yeah, anyways, so now you can also see how it looks like. So now this is at a 90 meter altitude, as you can see here. So yeah, there's no real restriction. There is a maximum altitude of 120 meters in the drone's profile, but this you can change. So in case maybe you even need to fly at 120, 130 meters, I suppose this in feet, it's like 400 or above 400 feet, if you have the permission to do so. Then yeah, you can also configure this. I know there's some customers of ours who are flying drones for mining, so over large mining quarries, and there they have the permit to also fly higher than the normal legal altitude, because of course that's their specific location. So yeah, in case you need to fly higher, also UGCS does allow you to do so. Okay, let me see. So for a cliff, you want the drone to fly going up and down the cliff, or you want to fly at the same height and then move higher and then the other height. Okay, anyways, from what I understand, you're also flying, you need to scan the cliff, correct? I maybe one thing, it's not really that much for LiDAR surveys, it's more for photogrammetry, but in case maybe you need to scan some steep cliffs, especially the faces of cliffs, actually GCS also does have possibility to do vertical scans, and maybe this at the end might be useful for you. So here we do have also the vertical flight patterns. This is available here in the vertical scan, and I'll just kind of place it here, but yeah, this is more for doing cliff scans. Also, I know for mining surveys, sometimes this can be used for scanning high walls. And so with this pattern, maybe this is what you meant. So you can actually do those vertical scans, which can be used for, again, for rock faces, for dams. And yeah, so here you can set, for instance, the minimum height of the scan, the maximum height, and then with this, the drone can fly up and down as it's scanning this wall. So this can also be useful. Okay. Another question I see. So does UGCS Enterprise include multi-drone capabilities, or do we still need Commander for synchronized multi-drone operations? I would say it depends on how you foresee controlling these drones. So even with Pro license, you can have multiple drones connected, up to 3, like I mentioned. So Pro and Expert up to 3, Enterprise up to 10, Commander unlimited. But here the key is how synchronized you want it to be. Because so with standard licenses and standard UGCS, you need to select a drone that you want to use. Then you select the route that you want to use, and then you upload the route to the drone, and then you can start. And then you do the same for the other drone, right? But if you want to, for example, be able to just press one button and have the drones take off simultaneously, then in that case, I would recommend looking into Commander. And yeah, if you're interested in this, then also we can talk separately, plan some call for that, and I can explain more how Commander works. But yeah, so with the GCS Commander, it's a separate app that runs side by side with normal GCS that you see here. And then with that, you can do exactly what you're asking for. So you can assign routes to drones, and you can, for instance, upload with just one press of a button, and you can have multiple drones take off and fly the mission. Okay, so I think that I have answered most of the questions that you guys had. Actually, I think you had quite interesting questions in this session. Now, if you're interested in getting started with GCS, so actually, if you go here to our site, then it's also possible to just get GCS for free because we have GCS open license, how it's called. So you can just go to sphengineering.com or gcs.com. And then here under products, you can go to UGCS. So that's the main site. You can, of course, read more about it, understand what drones are supported, and so on. So you can dig through and do your research on it. And once you think you're ready to start, you can click here on download UGCS for free. And with this, you can get the free license of UGCS, which is the UGCS Open. The installer is the same as the normal license, but there are some, of course, limitations for the open license. Number one is that the routes can only be up to 250 meters in distance, and you can only use 2 routes per day. So that's the limitation for the open license. But of course, if you want to do LiDAR surveys, you will need to fly larger missions typically, and usually also do multiple routes, of course, per day. So then for that, again, let me just go here in the main page here. Now let's go into licenses. So this is our shop, and so you can see we have just 3 licenses here. So Pro, Expert, and Enterprise. I'd say, since I know a lot of software companies, they tend to cut out perpetual licenses, but in our case, we still have them. So I would recommend looking at these. So what perpetual license means in case of GCS is that you own the license, right? So you own it for life. It does include the support and updates for the first year. So this means that within the first year after you purchase, you get access to new versions, access to customer support, and so on. After this first year, you still can use the software. So it doesn't end, you don't lose access, you can still use your existing version. In case you also want to get updates and you want to get access to the latest version, then you can just renew your annual support pack. This will also depend on which license you are using. Also, in case maybe you want to start out with one license and then upgrade to another one, it's also possible. So for instance, you can, let's say, start out with Pro license, and then you won't have to buy a new Expert license unless you want to. So then you can simply upgrade it. So also we offer that. So if you go here in our shop, then you can also see we have this upgrade your license. And so with this, you can, for instance, upgrade Pro to Expert, Pro to Enterprise, or Expert to Enterprise. And it's also a good way how you can, sort of dip your feet in the water, so to say, with one license and then, get started. But yeah, in short, how are these licenses different? So pro license, it is for your mapping and photogrammetry needs. It does not include LiDAR, does not include also smart AGL. So this is kind of limited to mapping. Next, the expert license. That's the one we recommend for most people because here you'll have access to most of the things you will need. So photogrammetry tools, LiDAR tools, smart AGL, some new interesting features that also will be coming out to expert soon. And also if you plan to do maybe some missions with some geophysical sensors, such as ground penetrating radars, echo sounders, magnetometers, also expert is the license to go to. And enterprise, it's a license more, for team use. If you want to have it, installed in some central computer, some local cloud, or if you want to use our SDK, so then also that's what the enterprise license is for. So yeah. Then yeah, I would say actually this is it regarding pricing. And yeah, so I think now we can probably wrap it up for today. So yeah, I just want to say big thank you to everybody who came today to listen, to ask questions. I think it was really interesting. At least for me, it was answering your guys' questions. And yeah, so hope to see you soon in future events. Make sure to also add me on LinkedIn and also add yourself to our Facebook group of drone pilots. And yeah, so let's see each other out there. Let's talk. And yeah, wishing you all a great day.